Alright, hello and welcome everyone to lesson 6 of indices. In this lesson we'll be learning about index law number 4, which is the very final one that we need to cover. This is what they call the zero index. Now very rarely does it happen in maths that you get to the final part and it's actually the easiest, but that's exactly what this one is. If you've been keeping up to date with the index laws so far, the first 3, then you're going to really enjoy this one because index law number 4 is quite possibly the easiest of the bunch. We'll also be doing a quick recap on some of the other index laws just to keep it fresh in your minds. So without any other further delay, I guess the final thing I will say is obviously make sure you got your book and pen. You will need it. There will be times where you'll be copying in notes and examples into your book, and just like has been the situation with all the other lessons, there will be some questions for you guys to do yourselves. There's only one other lesson after this one, and that's a lesson where we'll actually be combining all the different index laws together. So that'll be pretty fun too. But as you can imagine, you've got no chance of doing that without knowing, the index laws individually on their own. So this is the final lesson for that. As far as our topic tests for this exam, because that's actually next lesson is our final lesson for this topic. It'll be the start of next week. There'll be a relatively short, and as you can imagine, if you've been finding things easy so far, what will actually be quite an easy topic test for indices. Anyway, no further delays. Let's get straight into the lesson. Okay, so in this lesson, we will do a quick recap. You won't need to copy it into your books. Just a quick recap on index laws 1, 2, and 3. And then we'll get straight on to the main event. Index law number 4, the zero index, the final one that we need. All right, so I haven't included the recap. Okay, let's throw in a bonus page. Here we go. All right, so quick recap. Again, you won't need to copy this into your books. We'll just do one question of each just to refreshen your memory of what we've covered so far. Like I'm saying, the more frequently you see stuff, the less likely you're going to forget it. All right, so what was index law number 1? All right, this was the multiplication one. Let's say you've got minus 7 a cubed times 3 a to the 5. All right, so here's a very stock standard index law number 1. That minus 7 and the 3, they're not powers, they're just ordinary numbers. How do we do that? Well, we'll just do it. Since they're normal numbers, we'll just use normal maths. Minus 7 times 3, right? 7 3s are 21. You've got a negative there, throw it in the front. You've got your minus 21. All right, now when we move on to the A's, notice these A's have the powers. This is where we're going to be using our index laws, right, for the indices. A cubed, so now I'm looking at the A's. A cubed times a to the 5. And again, index law number 1, keep the base the same and add the powers. So that there gives you the correct answer for that question. What was index law number 2? Well, they were the questions where it was, instead of the multiplication, we were dividing. So let's say we have this question here. We'll go 24 x to the 7 divided by 8x squared. All right, so in this particular case, how do we do this question here? That 24 and that 8, are they just normal numbers or are they powers? And so hopefully you'd say, hey, they're normal numbers. So for normal numbers, we're going to divide just like normal. What is 24 divided by 8? Again, if you hated your 8 times tables, which almost everyone does, let's be honest, you can always use your calculator, right? You're in year 9. Either way, you get 3. Moving on to the x's, notice those x's do have powers. So this is where we would use our index laws. Index law number 2, when dividing, base stays the same and you take away the powers. So you're not with an x to the 5 there. And that's your final answer for the second question. And index law number 3, this was the one that we covered in the last lesson. This was the one that's called the power of a power. Looks confusing, but as we discovered, was just as easy as the first two, really. Let's say we have 6m to the 10, and the whole thing is squared. All right, so again, we're looking at that 6. It's an ordinary 6. It's been squared. 6 squared means 6 times 6. Right, 6 sixes are 36. When we deal with the m, it has a power of 10. So we have this power, and then there's this additional power above it. This is the power of a power type scenario. When you see a power of a power, this is index law number 3. And what was the shortcut? Keep the base the same, and you multiply the two powers. So you should have ended up with an m to the 20. If you've forgotten any of those 3 index laws, before you move on to the next law, you can still do this one, that's no dramas. Index law number 4, we won't need any of these index laws for this lesson, but before you do the next lesson afterwards, definitely you may want to go back and look at the appropriate lesson or corresponding lesson just to make sure that you're good at your 4 index laws. Otherwise, the very final lesson, you're going to really struggle with. All right, so there's our recap. Now on to officially the new thing for today. This is our heading. These are our notes. Can you please pause the video and get these things copied into your book? Hopefully you read it as you wrote it, but if not, in this lesson we will learn what to do when we end up, maybe a hyphen there, I'm not sure, with a zero index. And just to give you a massive clue, there it is in the bubble, officially the zero index law. Here you've got a, which is just a pronumeral, right? That could be any number, right? A is some unknown number. It could be 5, could be 7, it could be minus 2000. A is a number. If it has a power of 0 or an index of 0, you can see it's equal to 1. So I guess that's the answer to the big question. But anyway, I'm going to get you to consider this. I want to show you why that actually is the case, right? Don't just take my word for it. You don't know. They might have just got me out of the street. I'm actually going to show you why this cloud is actually true. And to do that, I've chosen this random example, x squared divided by x squared. Now we learnt with the second index law, we know what to do with division, right? So using law number 2, so using index law 2, x squared divided by x squared, we know law number 2, keep the base the same. And then what do you do with the powers? When dividing, the powers minus. So 2 take away 2 gives you 0. So very truthfully, x squared divided by x squared is equal to x to the power of 0. However, that's what we learned a couple lessons ago. But you learned back in primary school something even more trivial than that. What is 7 divided by 7? Right? It's 1, right? Well, what about 5 divided by 5? It's also equal to 1. What about, 23 divided by 23? And you say, hey, 23 goes into 23 once. The answer is 1. Every time you divide a number by itself, you always get the answer 1. And that's exactly what we have here. We've just said x squared divided by x squared is equal to x to the 0, which actually is true, right? It is. However, x squared divided by x squared, right? X squared some number. When you divide it by x squared itself, this is a number divided by itself. It'll also be equal to 1. So since x squared divided by x squared is equal to x to the 0, and x squared divided by x squared is also equal to 1, what does that tell us about these two things? And that is Therefore, x to the 0 must actually be equal to 1. They're the same thing because they're both what x squared divided by x squared is equal to. Right, so how do we get that? Well, in the first situation, we use index law number 2. In the second situation, we just used what we already knew about numbers. When you divide a number by itself, you get the answer 1. And so logically, those two things must be equal to each other. Note that x could be any number in existence. So we've just shown quite simply within a couple minutes here that, the number 10 to the power of 0, if you have your calculator with you, and I know some of you will, actually type that in your calculator, right? And if you've never tried this before, you can actually put a 0 up in the powers. Press your, index button and put a 0 up there. Type it into your calculator and press equals and see what you get. It ends up being the value 1. And if you want to try it again, change that 10 to something like, 2.4 to the power of 0. Type that into your calculator and press equals. And you'll notice you actually get the value 1 as well, right? It doesn't matter what the number is. We've just shown that any number, if it has a power of 0 above it, it'll just become the value 1. And that is index law number 4. Let me show you with some actual examples how quick and easy the questions will actually be. Right, before we go on and do that, make sure you've got this page copied into your books. Once that is, we'll move on to our actual examples. Simplify and evaluate where possible. Evaluate just means, I know, again, it looks more complicated than what it is, but evaluate just means find the actual value. Some of these ones will just have a value and you can write it in. There won't be any, X's or Y's in the answer at all. Sometimes there might be. Let's have a look. All right, so if you look at the first one, 5 to the 0, we've just learned index law number 4, any number, right? Any number at all. If it has a 0 power, then it will just become 1. That's your answer for the first one. Let's look at number 2. Here you have y to the power of 0. And again, I don't know what y is, and it does not matter. Any number to the power of 0 will just become a 1. You can see it's not that bad, right? You can see why this may quite possibly be the easiest of all the index laws. Question 3. Notice the x is to the power of 0. So what will that x become? The x to the 0 will just become a 1. So that's a 1, and notice the y cubed is still there. So you could write this as 1y cubed, or, you might remember if you got a 1 in front, you don't actually need to write it all. You could easily just as well write it as y cubed, and you'd get full marks in your exam. In actual fact, most teachers would prefer you to just write y cubed. But, you could put the 1 in front. That's still correct. And the final one, by the way, I've actually got 7 examples, so don't get too excited. There are some more examples. I've tried to make them as hard as I possibly could. Example number 4, again, it looks like it might be a little bit tricky. You got this xy cubed. That whole thing is some number. I don't know what the number is. But you got xy cubed. Check it out. The whole thing is taken to the power of 0. So I don't know what this number is, but it is a number. It's been taken to the power of 0. So the whole thing will become a 1. Right? Any number taken to the power of 0 will just become a 1. All right, make sure you have these examples copied into your book. If you haven't done it yet, you might want to pause the video because I'm just about to flip on over to the next page. All right, final 3 examples for this lesson. 3x to the 0. In this particular case, that 3, is that 3 to the power of 0? No, the 3 is just a normal 3, right? Technically, it has a power of 1 there. So the 3 will stay. But what happens to the x to the 0? That would just become a 1. right, the x to the 0 would become a 1. So here you actually have 3 lots of 1, or in other words, just the number 3. This next one is different. It looks almost the same as 5, except you've got these brackets. And what those brackets do is they tell us, well, it's not just the x that's to the 0. In this case, everything has been taken to the power of 0. And as you know, index law number 4, anything taken to the power of 0 just becomes a 1. So both the 3 and the x both turn into a 1. Technically making it like a 1 times 1 situation. In other words, I've just put the 1 there. All right, the final question is actually just technically like 3 mini questions combined. 3 to the 0, right? That just becomes a 1, right? What about 3x to the 0? What's been taken to the power of 0? It's just the x. So just the x becomes a 1. So this is actually like 3 times 1. In other words, you end up with 3. And over here, the final term, here you've got 3x all to the 0. So all of it becomes a 1, giving us a final answer of 5. All right, that's it for our examples. Hopefully that made sense. If you need to look back over any of the examples, please do so before moving on to the questions. With that being said, let's go. All right, you know what to do. Copy the questions into your books, pause the video, try your best. If you get stuck on a question, don't stress, just try your best, answer it to the best of your ability, and don't stress because I will put the correct answer in afterwards. But don't be lazy, right? Don't leave it blank. I do want you to genuinely try. It will help you, I promise. All right, so hopefully you've paused the video and you have answered these questions. I'm about to put the answers up right now. For the first one, you should have had the value 1. The second one, you should have had the value 1. The third one, you should have ended up with an x squared, right? The y to the 0 became a 1. And this one here, you should have ended up with like a 7 times 1. In other words, you should have ended up with a 7 there. So hopefully you did really good with the first 4 questions. There are some harder questions over on the next page, but hopefully these first 4 went okay for you. Let's move on, repeat the process. This is the final part of today's lesson. Final 3 questions, you know what to do. Pause the video, copy in the questions, attempt them to the best of your ability. Okay, so for the first one, you should have ended up with 5 lots of 1, or in other words, 5. This next one here, the whole thing would just become a 1. And for this final one here, that 2x, nothing's happening to that 2x, right? It's just still there. You got a 2x there. However, this next one, you should have ended up with 2 times 1, in other words, a 2. And the final one, this whole thing would just become a 1 because both of them were taken to the power of 0. As far as simplifying it, the 2x is not a like term. I can't combine it with the other 2 terms. It's got to stay separate. We're actually dealing with some, year 7 algebra now. So again, if you forgot year 7 algebra, hey, here's a little reminder. You can only add like terms. The 2x stays separate. The 2 plus 1 you can certainly combine and simplify though, giving us this, and this here would actually be your final answer for the last question. All right, hopefully, you've learnt a lot and you're feeling pretty comfortable about index law number 4, right? All it is, any number to the power of 0 will become a 1. And again, the teacher can try and create situations to try and make the questions a little bit trickier. But ultimately, the only takeaway you really need to take is if a number has a power of 0 above it, that number just becomes a 1. And that's really all there is to it. All right, if you have any questions, you know what to do. Leave them here on YouTube or back on Canvas. I'll help you the best I can. Hopefully you're feeling okay about it, and I'll see you guys for the next lesson. Okay, bye.